Deploying machine learning models, a step-by-step tutorial. Model deployment is the critical phase where trained machine learning models are integrated into practical applications. This process involves setting up the necessary environment, defining how input data is fed into the model, managing the output, and ensuring the model can analyze new data to provide accurate predictions or classifications. Let's explore the step-by-step process of deploying machine learning models in production. To get all the updates, please like, share, click on bell icon, comment on the video, and subscribe the video. Step 1. Data preprocessing. Effective data preprocessing is crucial for the success of any machine learning model. This step involves handling missing values, encoding categorical variables, and normalizing or standardizing numerical features. Here's how you can achieve this using Python. Handling missing values. Missing values can be dealt with by either imputing them using strategies like mean values or by deleting the rows/columns with missing data. Python copy code import pandas as from sklern.impute import SimpleImputer hash load your data equals pd.read_csv your _data.csv hash handle missing value simputer mean equals SimpleImputer strategy equals mean df numeric column equals imputer mean dot fit transform df numeric column. Encoding categorical variables. Categorical variables need to be transformed from qualitative data to quantitative data. This can be done using One-Hot Encoding or Label Encoding. Python copy code from sklern.preprocessing import One-Hot Encoder hash encode categorical variable hot_encoder equals One-Hot Encoder encoded features equals one_hot encoder dot fit transform df categorical column. Toarray encoded _df equals pd.DataFrame encoded features, columns equals one_hot encoder get feature names out categorical column. Normalizing and standardizing numerical features. Normalization and standardization transform numerical features to a common scale, which helps in improving the performance and stability of the machine learning model. Standardization, zero mean, unit variance. Python copy code from sklern.preprocessing import standard scalar hash standardization scalar equals standard scalar df standardized column equals scalar.fit transform df numeric column. Normalization, scaling to a range of 0, 1. Python copy code from sklern.preprocessing import min max scalar hash normalization normalizer equals min max scalar df normalized column equals normalizer.fit transform df numeric column. Step 2. Model training. Once the data is preprocessed, the next step is to train the machine learning model. Here's a basic example using a simple linear regression model. Python copy code from sklern.model_selection import train_test_split from sklern.linear_model import linear regression hash split the data into training and testing sets equals df.drop target column axis equals 1 y equals df target column x train x test y train y test equals train test split x y test size equals 0.2 random state equals 42 hash train the model equals linear regression model dot fit x train y train. Step 3. Model evaluation. Evaluate the trained model to ensure it meets the desired performance metrics before deployment. Python copy code from sklern.metrics import mean _squared error r2 score hash predict on the test city pred equals model.predict x test hash calculate performance metrics equals mean _squared error y test y preds r2 equals r2 score y test y pred print mean squared error print fr squared r2. Step 4. Model serialization. Serialize the trained model to save it for later use. This can be done using libraries such as pickle or joblib. Python copy code import joblib hash save the model joblib.dump model model.pkl hash load the model loaded model equals joblib.load model.pkl. Step 5. Setting up the production environment. To deploy the model, set up a production environment. This often involves creating an API using frameworks such as Flask or Fast API to serve the model. Example with Flask. Python copy code from Flask import Flask, request, JSONify import joblibop equals Flask underscore name underscore hash load the model equals joblib.load model.pkl at app.route/predict, methods equals postdef predict, data equals request.get underscore JSON force equals true prediction equals model.predict, data input, return JSONify prediction 0 if underscore name underscore equals underscore main underscore, app.run debug equals true. Step 6, Model monitoring and maintenance. After deploying the model, continuously monitor its performance to ensure it remains accurate over time. This involves tracking performance metrics and updating the model as needed based on new data and changing conditions. Deploying machine learning models is a multifaceted process that involves careful data preprocessing, model training, evaluation, serialization, and setting up a production environment. By following these steps, you can ensure that your machine learning models are effectively integrated into practical applications, providing reliable and accurate predictions.